There are techniques available to chemists to help determine empirical and molecular formulas of unknown compounds. Here's an example of a simple combustion device used to analyze substances for carbon, hydrogen, and sometimes oxygen and nitrogen. It helps chemists determine the mass percent of each element in an unknown compound. First, a known mass of sample is placed in a furnace. Upon heating with oxygen, the sample will combust and form carbon dioxide, water, and other byproducts. The products will then pass through a series of filters, including a carbon dioxide absorber and a water absorber. Other filters can be used to capture other products to determine the presence of elements other than carbon and hydrogen. By measuring the masses of the absorbers before and after the experiment, the mass of the carbon and hydrogen in the unknown sample can be determined. Let's do one example. Combustion of 0.225 grams of an organic compound containing carbon, hydrogen, and oxygen yields 0.512 grams of carbon dioxide and 0.209 grams of water. The sample's molar mass is found to be 116 grams per mole. Find the empirical and molecular formulas. Here's the equation, unbalanced of course, because we do not know the molecular formula. But it does illustrate that the carbon from the sample is converted to carbon dioxide and the hydrogen is converted to water. We'll find the oxygen of the sample later. First, let's identify the amount of carbon and hydrogen in our sample. To do this, I'll take advantage of the percent composition of carbon in carbon dioxide and hydrogen in water. I have another video explaining the percent composition by mass. Here, CO2 has 27.29% carbon by mass, and water has 11.21% hydrogen by mass. Multiply the carbon dioxide mass by 27.29%, or 0.2729, and multiply the water mass by 11.21%, or 0.1121. The masses for carbon and hydrogen are 0.140 grams and 0.0234 grams respectively. These are the masses of carbon and hydrogen that came from the original sample. The remaining mass, of course, is oxygen. Subtract from the initial sample mass to find the mass of oxygen. Now we know the mass of each element in the sample. Let's find the moles and the mole ratios of the elements for the empirical formula. The empirical formula is the simplest whole number ratio of moles of elements in a compound. We have the masses, so now we can use the atomic weights to convert to moles of each element. To find the simplest whole number ratios, we can divide by the smallest moles, 0.0039 moles from the oxygen moles. The answers are the simplest whole number ratios, and the empirical formula is C3H6O. Let's find the molecular formula next. The molecular formula is always some whole number multiple of the empirical formula, represented here by the letter N. N is the ratio of the molecular formula molar mass to the empirical formula molar mass. Here, 116 grams per mole over 58.09 grams per mole equals a ratio of 2. We can distribute the ratio of 2 and find the molecular formula, C6H12O2.